Now we'll talk about another consequence of Lorentz transformation called as length contraction. So let us see what length contraction is. Now consider a frame. So this is say K dash frame and this is K frame. So K dash frame is a moving frame, and in the moving frame say there is a rod. Okay, and length of this rod in the moving frame is the proper length, because a person in the moving frame, when he calculates, he will find that the length of the rod is actually x2 dash minus x1 dash. Now make the transformation. So when you make the transformation, look at this transformation. So what you will get, you find a gamma. I'm not writing 1 by, so remember what was gamma. Gamma was 1 by root over of 1 minus v square by c square. So I'm not writing it again and again to save my time. I'm just writing gamma. So gamma, so conversion says what, x2 minus v t2. Agreed. Now what is the second conversion says? The second conversion says there will be a gamma x1 minus v t1. Now see that if I do x2 minus x1, then x2 minus x1 is the length of this rod in this frame. Okay. Now I assume the person in the K frame measures the length of the rod simultaneously. So if it measures the length of the rod simultaneously, then T2 will be equal to T1, because there is a simultaneous measurement of the rod. So what am I left with? I am left with gamma x2 minus x1. So you see that, so I can write proper length by gamma is equals to length measured. So what do I mean by proper length? Now proper length is the length measured in the frame itself. Since the rod is in the moving frame, so the person in the moving frame, whatever length he will measure of the rod, that is the proper length. And this L is the length that is measured by the person in the another frame. Agreed? So remember this formula and let us try to solve a problem to understand more. So consider this example. It is said that there is a spacecraft, okay, most probably cylindrical, and the diameter is given in the perpendicular direction. So diameter is not gonna change, so forget diameter, look at the length. So when it was at rest, the length was 120 meter. It means this is the length calculated by the stationary observer. So this is the proper length. Agreed? Because this is the length calculated by the stationary observer. So you are given proper length as 120 meter. Now suddenly there is another observer here. He is also stationary, but he sees the spacecraft is moving at a velocity of 0.99 c meter per second. Now what will happen? So it is given if the spacecraft now flies by the observer with the speed of 0.99 c. So there is another observer again on the stationary ground, and this time the spacecraft is flying at 0.99 c. So the person in the spacecraft, he will measure. So consider this person who initially measured the length of the spacecraft in 120 meters. Say he gets into the spacecraft and drives the spacecraft. So this person will always measure the velocity of the spacecraft, the length of the spacecraft as 120 meter. So what is the proper length? The proper length is 120 meter. Now the question is, how much length does this person measure who is outside the spacecraft? Actually, this person will measure a length which is smaller. This is what is meant by length contraction. He will measure a length of 17 meter. It's not because that he measures the length of spacecraft because it is very much far away or something like that. No, even if the spacecraft is very near to his site and flies by with a speed 0.99 c, the observer, this stationary observer, will see that this moving spacecraft has a length of only 17 meter, though its actual length is 120 meter. So this is the meaning of length contraction. So what is length contraction? That when an object, so consider when an object with a particular length L, it moves with a particular velocity v, then any person on the other rest frame, not in this frame, in the rest frame, will measure a length which will be always less than the actual length. This is what is meant by length contraction. So this is a consequence of special relativity. So Lorentz transformation has another consequence. That consequence says that there is a contraction of length. So you can solve many other problems like this to understand. So once you get a practice, you will understand. So the main point is always about finding what is the proper length, and the relation is here. Okay. So it is little bit different from the time relation. Remember the time relation? In the time relation, the proper time was like this. The proper time interval will be here. Okay. And gamma will be multiplied with the proper time, and that will give you the time in any other interval. So this formula is a bit different from this formula. Here, the gamma is divided in the denominator. So with the proper time, so proper length is up and gamma is in the denominator, but in case of time, the gamma is multiplied with the proper length, proper time. So in this way you need to see what who is where, agreed, and you need to solve some problems. So this is all about length contraction. Now we'll understand one more consequence of Lorentz transformation, that is relativity of simultaneity. So it's all about how events can be seen occurring in a different way to different observers. So we'll discuss in the next lecture about that part.